Okay, welcome to day 2 of fractions. Today we're going to go into adding and subtracting fractions with like bases. It's a little bit different when the denominators are different, but today we're dealing with the easy stuff of adding and subtracting fractions with common denominators. Common denominator just means that the bottom numbers of the fractions you're adding or subtracting are the same. When adding and subtracting, the denominators have to be the same. You cannot add and subtract fractions that do not have the same denominator. Multiplication and division is different. That's a whole different set of rules. But adding and subtracting, they must have a common denominator. Today, the fractions we're working with will already have a common denominator, so we don't have to worry about that step. Later on, we will have to deal with that as it comes up. So, starting at the very top, number 1, write all mixed numbers as improper fractions. And remember, a mixed number is something like number 27 down there below. A mixed number has a whole number out front with a fraction behind it. So that'd be -3 is the whole number, and 3/4 is the fraction. So that's a mixed number. It's a mix of fractions and whole numbers. So we need to write those. When we get to them, we need to write them as improper fractions. Number 2, add and subtract the numerators and keep the denominators the same. So the numerators are added and subtracted, and the denominator stays the same. Okay? And then simplify. Simplify just means reduce it. And just make sure you're looking at a fraction and seeing, can you reduce it? You constantly need to look at your answer. Can I reduce it? So let's look at number 22. 22, as a check, number 1, do they have a common denominator? Yes, they do. And all of these today will have a common denominator. So then we just have to deal with the numerator. The numerator is the number on the top. So we just add 1 and 5. So 1 plus 5 is 6/12. A lot of you might think, okay, we're done. Cool. No, we need to look at that. Can it be simplified or reduced? Well, what number goes into 6 and 12 evenly? The way I like to look at this is go, okay, the numbers that I can multiply to get 6 are, I can multiply 1 and 6, that's 1 times 6, and I can multiply 2 and 3. Okay, 2 and 3. 2 times 3 is 6, 1 times 6 is 6. Then I look at 12. What numbers can I multiply to get 12? Well, I can get 1 and 12, 2 and 6, and 3 and 4. Right? 1 times 12 is 12, 2 times 6 is 12, 3 times 4 is 12. Then I want to look and see what is the biggest number that appears in both of those lists right there. Well, I can see 3 appears, but that's not the biggest number. I would say 6 is the biggest number that appears in both of those. So then that is what I want to use. So I'm going to divide by 6, divide by 6. 6 divided by 6 is 1. 12 divided by 6 is 2. 1/2, which is true. 6 is half of 12, so that gives me 1/2. Let's move on to number 23. Actually, yeah, let's do 23. Again, I have a common denominator, so I don't have to worry about anything. 11 minus 4, that is 7. The denominator stays the same, 7/15. It's like saying I've got 15 pieces. I've got a pizza with 15, it's cut into 15 pieces. I've got 11 of those pieces. I eat 4 of them. How many pieces of that 15-piece pizza do I have left? 7, okay? So 7/15. I look at that. There's only, to get 7, I've only got 1 and 7 are the only two numbers I can multiply to get 7. 15, I've got 1 and 15, and I've got 3 times 5. So I got 1, 15, 3, and 5. The only number that appears in both of those is the 1. And dividing by 1 won't help me. It won't do anything. So, and let me go through and do it. Let's just do that exercise. What if I divide by 1 on the top and the bottom? 7 divided by 1, 7. 15 divided by 1, 15. I get the same answer. So there's no reason to use 1 when I'm trying to reduce. Don't use 1 when you're trying to reduce. Look for a larger number. 1 won't help in reducing a fraction. Let's look at number 24. And remember, along the way, feel free to pause and rewind if you're not getting something. Fractions can be very difficult, so don't be afraid to pause this and rewind it and listen to it again. Again, we have a common denominator, the 3. The 3 is the same on both fractions, so I don't have to worry about changing the denominator. So then I just add the two top numbers, 5 and 2, that's 7. 3 stays the same. I don't change the denominator. It's like saying I have 5 of something and 2 of something, so there's 7 of that same something. So 7 over 3, okay, that is an improper fraction. The numerator or top number is bigger than the denominator, the smaller number. So all I need to do, this is a mini division problem. And it's always top dog goes in the house, okay? I say top dog goes in the house. The top number, not the bigger number, the top number goes in the house. So that means I do this. Top dog goes in the house. 7 divided by 3. Well, how many times does 3 go into 7? 2. 2 times 3 is 6. Subtract 6. I've got 1 left over. 3 doesn't go into 1. So this is my whole number. So that becomes 2. This is my remainder. So that is going to go on the top of the fraction left over. 2 1/3. Okay? That is how you convert an improper fraction into a mixed number. Let's look at 25. Now 25, I have to convert. I have a whole number out here in the front. I need to multiply and then add. Okay, so 8 times -1, that gives me a -8. -8 plus 5. That's going to give me a... Actually, this whole thing is going to be negative, so I don't even care about the negative, really. It goes out front. So I have an 8 times 1 is 8. Forget about the 8 times the -1. It's just 8 times 1 is 8 plus 5. That is going to be 13 eighths, -13 eighths, plus 4 eighths. Now I need to worry about my adding and subtracting integers. Well, basically I have a -13 plus 4. Well, if I look at a number line, I start at -13. I add 4. Which way do I go? I've got to go to the right. So I'm actually getting smaller on my negative side. So it's -13, I count backwards 4, 12, 11, 10, 9. So that gives me -9 eighths. Okay, -9 eighths. Well, again, my numerator is a bigger number. It's farther from 0, basically, than my denominator. So we know it's going to be a negative. So remember, our multiplication and division rules, if there's one negative, it's going to be a negative answer. Okay, so all I really care about is top dog goes in the house. My 9 goes inside, 8 comes out. 8 goes into 9 one time. 1 times 8 is 8. Subtract 8, I have 1. My whole number in my remainder is there. So I have 1, and this is all negative, and 1/8. Okay, so this 1 goes here, this 1 went here. And the answer was always going to be negative because this was a negative answer. Okay, move on to the next one. Now, these parentheses are just showing we're adding a negative, okay? So you don't have to worry too much about it. It's really all it is you're combining them. So when you combine, you add. So let's work on combining these things. So we first need to do this. The -5/6, that's fine. I don't have to do anything with it. I've got a -1 and 1/6. So this is going to be plus a negative. The negative just comes right out because we don't care about the rest of it. But we multiply that. 6 times 1 is 6. We add that, so that's 7. So we have 7/6. Okay? So what we want to do is combine the numerators. We have a -5 and a -7. Well, if I start at -5, and remember my whole adding good and bad. Well, if I add more bad to it, so that -7, that's going to go left on the number line. More bad means more left. We're subtracting. So a -5 and a -7, we combine the numbers and keep the sign. So that gives me a -12/6. Well, that is an improper fraction. I need to fix that. So top dog goes in the house. So let's put it over here. 12, top dog goes in the house. 6 goes out here. 6 goes into 12 2 times. 2 times 6 is 12. Subtract that, that's 0. So guess what? That's just -2. Because -12 divided by 6, a +6, remember, one negative is an odd number, so my answer is going to be a negative. And there's my answer, -2. This one's a little more difficult, but I want you to try it on your own. Okay, go ahead and pause the video, try it on your own. Remember, you got to convert the mixed number into an improper fraction, and remember what happens when you have two negatives. Think about that. Go ahead and pause the video and try that problem on your own. Now, what you should have got if you tried this problem on your own would be a -6/4, which can be reduced to a -3/2, which again can be turned into a mixed number, which is -1.5. Those would have been the answers if you got that one correct. Let's go to the application part of this. It's number 28. Amaya is making bracelets. She has a piece of string that is 12 1/4 inches long. She cuts off a piece that is 8 3/4 inches. How much string does she have left? Okay, well, if you're cutting string off of something, are you adding it or subtracting it? You're subtracting it. She's not putting a piece on, she's cutting a piece off. So if the original amount was 12 1/4, she's taking off 8 3/4. So we need to convert both of those mixed numbers into improper fractions. So again, I multiply and add. So 4 times 12 is 48, plus 1 is 49. Then denominator stays the same. Subtract here, 4 times 8, I multiply and add. 4 times 8, that's 32, plus 3 is 35. Denominator stays the same. 49 minus 35. The denominator is going to stay the same, so I'm just going to go ahead and write it. Well, 49 minus 35, 14. Okay, so I have 14/4. That can reduce, and one quick tip, you can reduce over and over and over as long as there's still a number that comes out. I'm going to start with something simple because both of those numbers are even numbers. So I know they're both divisible by 2. I'm going to start there. 14 divided by 2 is 7. 4 divided by 2 is 2. Okay, there's nothing that goes into 2 that goes into 7 evenly, except 1. And remember earlier, 1 doesn't help us when reducing. So I have 7/2, or 7 halves. Well, I want to see how many times does 2 go into 7? Well, 2 goes into 7 3 times. 2 times 3 is 6. That leaves 1 left over. So if she had 12 1/4 inches of string, and she subtracted 8 3/4, she should have 3.5 inches of string left. I'm going to put inches. Okay? 29 looks a little difficult, but let's try it anyway. Marcus is skiing. He is 860 1/10 feet up the mountain. He descends to 450 7/10 feet. What is his change in elevation? Well, he was at 860 1/10 feet. He went down. If he went down, did he add or subtract elevation? He subtracted elevation, so it's minus 450 7/10. This problem is not as difficult as you might think it is. Well, 10 times anything, oops, let's do this. I got to multiply to convert this thing into an improper fraction. Multiply and then add. 10 times 860, whenever you multiply anything times 10, you just add a 0 to it. So that gives me 8,600 plus 1. So I have 8,601 feet all over 10. minus 10 times 450, that's 4,500, plus 7, 4,507 over 10 equals. And then I subtract. Now, this one might be a little bit difficult. Let's do some long subtraction. How about that? Well, 11 minus 5, I need to borrow. I can't borrow from a 0, so I got to borrow there. That's a 5. That would become 10, which would become 9, because now I can borrow. 11 minus 7 is 4. 9 minus 0 is 9. 5 minus 5 is 0. 8 minus 4 is 4. So we're at 4,094 tenths. So we're at 4,094 tenths. Then I just figure out, okay, how many times does 10 go into 4,094? Well, it goes, put it down here, equals 409 and 4 tenths left over. Am I done? No, that fraction can be reduced again. That's a simple one. I know 2 goes into both of those, so I'm still left with 409. 2 goes into 4 2 times, 2 goes into 10 5 times. That's my final height. That little mark right there means feet. Okay? Try the last one on your own. And don't forget, you got to convert to an improper fraction. And it says right here, we're going to add, so we're going to have to add those two numbers together. And they already have a common denominator. So try that one on your own, see how you do. And I will get back to you next time.